Hello, welcome to Math Vibes. Today in this video we are going to learn about midpoint theorem in class 9 chapter 8 quadrilaterals. Very important theorem. This theorem usually comes as state and prove midpoint theorem. State and prove midpoint theorem. Now let's see how the theorem goes. Statement is the line segment joining the midpoint of any two sides of a triangle is parallel to the third sides and is half of it. Means if D given is in triangle ABC, if D is the midpoint of AB and E is the midpoint of AC, then DE will be parallel to BC. Also DE will be half of BC. Now this we have to prove. Okay. Now for this what we will do a construction and we will produce DE to F and we will extend this CF in such a way that CF is parallel to BD, okay, or DP. Okay, CF is parallel to BD. Now this is by construction. Now how will we prove it? See, in this triangle, if you have a closer look, then first of all we want to prove that these two triangles are congruent. Now we will see, this is given if D is the midpoint of AB, then AD is equal to DB, and if E is the midpoint of AC, then AE is equal to AC, right? This will be given to us. This is already given to us. And also see, if by construction we have done that AB is parallel to CF, then these two parallel lines and AC is a transversal. Okay, these two parallel lines by construction and AC is a transversal. What does it mean? It means that angle 1 will be equal to angle 2. Alright. Why? Reason is alternate interior angles. Also, whenever a cross is formed, we always have vertically opposite angles. That means angle 3 will be equal to angle 4. Now see, if I want to prove these two triangles to be congruent, now I have enough conditions for that. Okay, right? How? AE will be equal to CE. Angle 3, this was given. Angle 3 is equal to angle 4 vertically opposite angles and angle 1 is equal to angle 2 alternate interior angles. So that will prove that our two triangles are congruent. Now let us see how do we have to write it. We will write in triangle ADE and triangle CEF, angle 1 is equal to angle 2 alternate interior angles. Angle 3 is equal to angle 4 vertically opposite angles. AE will be equal to CE, given E was the midpoint of AC, that is why we can write it like that, and therefore the two triangles are congruent by AAS criteria. Now if these two triangles are congruent, if these two triangles are congruent, then what do we have? We can say that AD will be equal to CF by CPCT. Now this AD is equal to CF by CPCT, right? By CPCT. Now we have written that AD is equal to CF by CPCT, but also it was given that AD is already equal to BD because D was the midpoint. Now how it is possible that that one side is equal to both the other sides? This can only be possible if these two sides are also equal. So that means BD is also equal to CF. From 1 and 2 we can say that if AD is equal to CF and AD is equal to BD, then BD should also be equal to CF. This we have found by from these two conditions, and we already had that this BD was parallel to CF by construction. In construction we have done this only, that BD is parallel to CF. So if that will prove that DBCF is a parallelogram, because in a quadrilateral if we have one pair of sides which are equal and parallel, then that quadrilateral is definitely a parallelogram. Okay, and if it is a parallelogram, and these two sides we have already proved that they are parallel and equal, then similarly I can also prove that DF is parallel to BC also and DF is equal to BC also. Right, so we can prove that DF is parallel to BC. So for the first part I have written that DF is parallel to BC, but if the complete DF is parallel to BC, then half of DF will also be equal to BC. Okay, so already we have done that DE is equal to EF by CPCT. So अगर पूरा इस BC के equal है तो उसका half भी equal होगा. right? That means parallel hoga. We are going to prove parallel first na. So DF is parallel to BC, so DE is also parallel to BC. That was the first part of the theorem that we have to prove. See, that was the first part of the theorem that you have to prove. Now for the second part, I want to prove that DE is equal to half of BC. Okay? Now take full DF. Just now we have done that DF is parallel to BC. Right? So DF is parallel to BC means DF is equal to BC also, because we have already proved that DBCF is a parallelogram. So if DF is equal to BC, then DF can be written as this whole DF can be written as DE plus EF. So we have written DE plus EF. Okay, this is equal to BC. Now already these two triangles we have proved out to be congruent. Okay, if they are congruent, then DE is equal to EF by CPCT. DE will be equal to EF by CPCT. Already we have proved that the triangles are congruent. Okay, that means I can write in place of, see here we have written DE plus EF is equal to BC. That is DE plus EF is equal to BC. This we have proved as number 5. Okay, now if DE and EF are equal, as we have proved already over here, we have proved that DE is equal to EF. Then in place of, okay, we have already proved that DE is equal to EF by CPCT. So in place of DE I can write EF, or in place of EF I can write DE. So I have written like that. It is equal to BC. That means 2 times DE is equal to BC. So DE is equal to half of BC, and it was to be proved in the first part. We have proved that DE is parallel to BC, and in the second part we have proved that DE is half of BC, and that was about midpoint theorem, hence proved. Okay, and this midpoint theorem is very important. All right, do practicing, keep on learning, and don't forget to click on the subscribe button. Bye.